separated form. What you need is the product analysis thereafter. So as we have seen that characterization means you need to have all physical parameters in place, all the data interpretations in place, and therefore we need to have a lot of patience while handling the column chromatography, right from the reaction step to product analysis. Now, the matter of concern for most of the researcher is lack of patience, very less time for pursuing their research in the laboratories, and still they need to achieve the separation and isolation according to their own agendas of their research projects. But because of this slowest step of the reaction sequence, many a time people either drop this particular idea of using the column chromatography, or they drop this concept of purification from their whole project. However, because of the time frame, if the project is devoid of any purification step, it means that you are losing out something which is really going to add value to your own biodata. Because isolation, if one achieves a proper isolation of pure compound through his or her research work, there is a lot of appreciation. Even if you can isolate one single constituent in your master of pharmacy, or if you can isolate 3 to 4 phytoconstituents during your PhD program, that is good enough sign of we usually appreciate a lot such kind of students who give that much amount of time for the isolation. That really adds into the arsenal of new molecules which are highly desired in the pharma industry, and that becomes a beginning for adding, say, a kind of a new molecule in the kitty of the medicines in future. But because of this deterrent step, many of us, we usually do not give such kind of projects to our students. Now, what is desired out of this is that, can we have something, some automated system wherein we can reduce this particular time of separation? Can we have something which is more automatic, wherein variations with regard to personal's handling or the kind of the mixing of the solvents, so a lot of errors can occur while you manually do this kind of separations. Can we have something as a substitute? So, my dear friends, I'm going to now shift your focus from the manual and more tedious systems into the automatic flash chromatography system. Now, while moving from column to the automatic flash chromatography system, we need to really understand the progression that scientists must have had while shifting from column to flash. Now, flash, that name itself means quick, faster, energetic, at a at the speed of lightning. Now, that kind of a system, if we need to really use, let us understand what kind of modifications people had done. So here you can see the scientist was using the same column that we talked about. He had an additional continuous flow of he ensured the continuous flow of solvent from the top, and then the kind of collection. So you need not have to worry about the input of the solvent in this manual flash chromatography system. However, you were still dependent upon the eluted fractions to be collected manually, and then you have to keep on testing them by your own. So it requires constant attention. It takes researchers away from performing synthesis. It means that this person who is skilled in doing synthesis is spending time in physically handling this particular system, and a lot of time is being wasted. It therefore reduces the productivity of a person or the laboratory. Now, what we are looking for is something that is easy to use. We can do more compounds at less time? Can we have high purity compounds? And can we have the system which is more reliable? So even while transition from simple column to manual and then manual to automated, you can see the comparison that manual one is time consuming, and the automated one that we are going to see is very faster purification. Manual needs a TLC, because once you collect the samples, you need to keep on testing them for their spectrum of distribution of the constituents, and therefore you need to have a TLC after it. However, now this system, which is going to have the detector at the end of the collection points, simply easily detects the flow of constituents which are being separated. Here we have the isocratic or step ingredient. As I was telling you, isocratic is there are going to be two different solvents, and then you can keep on increasing the polarity by adding the next polar solvent, and that step gradient has to be followed manually, and you have to keep the record of that. However, once you fix some program in the automated machine, linear gradient system works automatically, and it improves the separation of the phytoconstituents. Now here the need is the mixing of solvents has to be done by hand, and here the machine or the pumps are designed good enough to take the commands of linear increment in the gradient or linear increment in the polarity of the solvents that you are going to use for separation. Manual has absolutely low resolution, and here in automatic we have the pre-packed columns that we are going to see in detail in the coming slides. Now, what was desired earlier was that right from preparing our sample to the product analysis, the most time-consuming patch of your research is the purification step. Now, as desired by all of us, the machines have now come up, which we call them as flash chromatography, which has drastically reduced. Almost 40% of your time has been reduced if you use this kind of systems. So keeping all other things constant, you can see that the automatic reaction and the purification process is going to have less time, and therefore I'm going to introduce you with the machine that we have in our department, and we have been using it for quite a long period of time. This is called as CombiFlash companion system. Now what you can see here in this is a very compact isolation machine, wherein you have an integrated platform which is computer driven. You have the column in place, you have the sample loading cartridge, you have the fraction collector, and then inbuilt you have the detectors as well. So on the basis of our requirements, so the researchers' requirements, the machines are there in place now, which are available for all of us to do a lot of research in this particular area, and wherein our concerns about the speedy completion of our experimentation, higher performance and better reliability is achieved. So what we have is that the whole process is properly monitored and controlled from your computer desk. You can have the liberty of making changes in the methods at any time without pausing the system. So once you set up your system, once you design what kind of solvents you are going to use for the separations, and which solvent shall be beginning with is has to be decided, and it could be isocratic, it could be you can use 4 solvents at a time, and the liberty of using the quantity of your sample is from 5 milligrams to 33 grams. So the sample loading and the column size, which has been made available by this particular company, which is Teledyne ISCO from USA, is that you can, if you are using this R&D as at your say postgraduate or PhD level, many times we have very less amount of extract for isolation. And for that matter, if you have this kind of machines, you can have minimum 5 milligram. If you have that kind of a compound wherein you need to separate certain constituents out of it, yes, it is possible for you, and maximum you can load 33 gram without any hardware changes in this machine. So it is built with easy to use software. We will see how we use that system. The best part is that it has got the same performance, higher productivity, it is reliable, and it is also having multi-channel technology. So it means that if you have more than 33 grams of your compound, and if you wish to isolate your constituent in a with a better yield, or we can say at a go for a higher volume of it, or if you want more amount of constituent at one go, you can parallelly have the multi-channel columns and the sample loading. So you can just multiply your yield by adding keeping on adding the different the channels along with this. So this kind of arrangement helps us in quicker isolation, isolation in quantity, and then those isolated constituent remains the basis for our further drug discovery. Now, high performance here is reliable fraction collection is there. What is really needed is identify where to change the fraction. So it means that if your machine is taking the solvents in a desired gradient, and then it is passing through your sample, going through the column, and then certain constituent is getting separated, how you are going to know where your fraction he is having which constituents? So that reliability of fraction collection, separation of fractions with say constituent A and with that of the other fractions wherein some other constituent is there, that needs to be smartly done by the machine. That is our need. So reliable fraction collection is an important thing. There should not be any spill out. All the fractions, if needed, if you desire, then all the fractions should be collected. And then this kind of a provision of the ready set columns. So ready for separation columns are available for use, which are disposable in nature. So if you have any question in mind, like can we use the same column subsequently? No. Once you handle one particular sample and use that particular column for separation, after the complete process is over, that column cannot be repeatedly used. This is a kind of a disposable column system which company has prepared. There are two pumps featuring high pressure gradient mixing. So whatever gradient that you wish to have between solvent A and B, whether you want it as 50-50%, whether you want as 70-30 or 80-20 or like that, even right up to 95:5 of solvent A to B can also be achieved, and that is possible through the softwares which are inbuilt with this system. So fraction tube sensing, it eliminates the spills. So it will never take one constituent right up to say 10 test tubes, and then again it is getting spilled into the next one. No, once the second constituent has started coming out, it will stop collecting or mixing it with the sample A. And then if you find that the total runtime that you had fixed has not delivered or has not separated the constituents which you are looking for, then you can really extend the runtime of your reaction separation purification process just by dragging the the spot of reaction purification process on the screen, and that runtime extension can be achieved without stopping that particular system. There is auto shutdown at end of the run. So what is really needed is give me a system wherein I'll remain in touch with that of our the whole process that is going on. I will be updated by the system at my work desk, or I can be looking at the computer screen how the process of separation is going on. So that is possible. Here the whole system is connected through internet, and it helps in acquiring, archiving and managing the data during the run. So you can really see whether the peak is generated, and if the peak is generated means that the detector has identified that there is some separation has taken place. There is some ingredient which has been now eluted. Now that peak has started going upwards, and then it will come downwards. Now, if the peak is going upwards, it means the elute has been taken into certain test tube. Now the test tube is having a volume of say only 15 ml, and if the sample is coming in say almost 100 ml of your elute, then number of test tubes would be needed. Say for example 10 ml if it is collected in test tubes, then you would need that complete fraction to be collected in 10 test tubes. Now, how I will know from which test tube number to which test tube number my compound is there? That message shall be given to me by the machine. So machine tells you that test tube number 15 to test tube number 25, compound A is dropped. So you can really enjoy picking up only those 10 test tubes out of the crate of test tubes, and you can achieve the solidification or the crystallization of that particular constituent, and you can move ahead further with that as a separated constituents. So immediately, if you summarize this, then that the whole system is almost ready. What you really need to do is you have to pick up your sample, load it at the top. These are the preparative, already the prepared columns are there, which are disposable in nature. There is no need to spend time in preparing the column for your isolation, and just you have to fix it in the machine. That is possible, and then you have to place this tray inside. So another advantage is that there are certain default methods which are pre-programmed. If those are suitable to you, you can pick up those and you can immediately start your separation run. Automatic column sensing is there. So it means that if you are taking only 5 milligram of your sample at the top, you would need a very small sample, means a 10-gram sample. However, if you are taking 33 grams of sample, then the column size will increase. This same column will not be of use. It will not cater to that increased sample quantity, and therefore a bigger column would be needed, and that choice is there with you. So if I use 330 gram column and I am loading 33 grams of my sample, then that is a compatible teamwork, and that the machine also quickly senses what kind of a column that you have fixed to the machine. And after this, if you have not added this rack inside, then the machine will not start, because the machine will sense that there are no collection test tubes at the bottom, and therefore there is no point in running this system. So there will be an automatic shutdown. So the system senses that you have added the test tubes for collection in the rack, and that is a bigger advantage. Putting the column is a very easy process. Just you have to lift this particular handle, lift it, and according to the size of your column, you can see there are 4 different kind of sizes are kept here as a different columns which are available as ready steps columns. So it's the smallest one is this, the bigger one, the another bigger one, and this is the mid size. So to purify 5 milligram to 33 grams, you can use different ready step columns, and the ideal understanding is that your sample size and the quantity of silica gel inside the column is not less than 1:10 proportion in the flash chromatography system. So as I was telling you, if you are taking 33 grams, at least the column should be of 330 grams of the silica gel inside it, which is of the flash chromatography grade. It's again a little bit different than the regular column chromatography. So simple snapping up of the columns can be there. No hardware changes are required, and you do not spend more than a minute to change or load the column in the system. So dry loading. Now, how to load the columns remains the question. So here, if you can see in the earlier one, there is a hole here at the top, and the column is placed here. So now loading a sample, you cannot load directly on the top of this column. So you have something on the top, which I am going to tell you how to load the column. So dry loading onto the column, if your sample is dry, yes, you can have it on the top of the column, but there is a space in between, right? This handle is there, and then dry loading can be done in the another capsule that you will see. If you are having, say, liquid sample, then you can have a syringe injection again at the top of the column. Solid load cartridge is there, or column stacking is there. So if you have more quantity of solvent sample, you can have the stacking of the columns as well. So equilibration of the column for input separation is needed. It means that when we say that equilibration means it is preparing the column for separation is there, and all the columns once they are fixed in the separation process, you have to first run the solvents without sample, equilibrate the column. So the solvent system gets, across the bed of the silica gel column, which is a pre-packed column, and then it equilibrates and gets the column ready for the desired separation through the sample that we are going to load at the top of it. So compounds that are soluble in mobile phase at beginning of are taken at the beginning of gradient. So what is this picture is showing is that if you are having a liquid sample, you can directly inject it on the top of the column. There is an integrated pipeline and valve system inside, which takes the solvents from the bottles through the gradient pumps, and then it mixes along with the sample and then carries that sample on top of the column, and then the separation is desired. Now what is expected is that the solvent system that you are going to use at the beginning, so the compounds that are soluble in mobile phase, so whatever mobile phase that you are taking, whatever constituents are soluble in that particular solvent will move first, and you will get the separation of the compound which is having more affinity towards mobile phase first out of the whole system. So it is very convenient to understand that. What we need to understand now is how to load the sample. So these are the different cartridges for loading the samples. So if you are having a solid sample, you can load it in this particular syringe kind of a system, which is right above the handle that we have seen, and below this handle we have the column placed. So they are either pre-packed. Many times question up comes when you have a sticky kind of a compound and how to load that, because either it is neither liquid nor solid, and those sticky sample is difficult to be loaded in this kind of system. So what is desired here is to prepare that sample, is to load it on the activated silica. So activated silica will offer the surface area needed for absorbing that particular extract on it, and once you have that adsorbed on the silica gel, you can load it here, and that will allow the solvent to pass across that particular bed, will leach out the desired constituents according to their solubility or affinity towards the solvent system, and it will go on the column first. So that kind of a arrangement is possible. And now here you can see that there is a possibility of directly having the column, and then you can directly have the liquid phase also. So this kind of a sample with undissolved material can be placed in the form of a series directly on top of the column as well. So all kind of samples have been considered while preparing this kind of flash chromatography system. So there is no inhibition whatsoever regarding the nature of your sample that you are going to try for separation. Any sample can be tried. So another thing that I was telling you was the column stacking. So if you feel that this particular height of the column is not good enough for allowing the separation of closely placed or closely related kind of constituents, then you can increase the height of the column by stacking them one above the other, or you can have them in parallel, one after the other. So both the possibilities are there, and however, this is this does not require any additional hardware if you performing the stacking of it. But if you wish to have them in parallel, then you would definitely need a separate hardware for performing this particular kind of a separation. Now, when this is needed, if your sample quantity to be taken for separation is quite big, say like if you are willing to have 100 grams of sample for separation, then in that case, as I was telling you, this particular machine, which is made for laboratory purposes, for R&D purposes, can cater only up to maximum 33 grams of sample. So if you wish to have 100 grams of sample to be separated at one go, then either you can go this way, stacking, or you can have the system in parallel. Now, what happens many times is that some of your sample may not come out of, even at the highest polarity, and you do not wish to miss out on those constituents which remain stuck in the column. So you can easily cut those ready set columns, and you can take out the sample along with the silica gel, and you can dissolve your constituent which has not been separated so far at the end of the separation process. So that possibility is also there, that you can cut and recover your compound which has not came out of the column during the process of separation. So now let us again review a little bit that TLC. Yes, we started with that, and then we know that it was a inherently isocratic kind of a system. Then we moved ahead and we saw that the same isocratic system can be used in the column chromatography. And if you really wish to now connect with the TLC and then right up to column chromatography, then the data that is generated out of TLC is very important while you fix the process parameters for the isolation in the flash chromatograph. Now, what are those examples? So I'll just simply spell out those conditions which ideally sets the whole program of separation in the flash chromatograph. The one amongst the requirement is that your compound should fall in the range of 0.1 to 0.5 of RF. So RF value should be in between this. So now how this information will come up? It will definitely come from the TLC. So this becomes a basis. If your isolated this constituent shows the RF range between 0.1 to 0.5, then it is possible to separate them isocratically, and then also very easy to isolate them on the flash chromatography. So the conditions that we have used in TLC help us about knowing the characteristics of the constituents, number one, through their RF value. Second, it gives us the information about the kind of the solvents that you had used while development of that plate. So you have the basic information that the mix of such solvent system was used, and that has given us the desired RF value of those compounds between 0.1 to 0.5. So this basic information is taken, and then this is transmitted into a kind of a computer feed program in the automatic flash chromatography. So, and one good thing is that if the sample moves with or just behind the solvent front, आपके TLC plate पे अगर वो just solvent front की तरफ में है, इसका मतलब है कि ये compound जो है ये पहले निकलेगा आपकी column chromatography से या flash में से. So the one who is moving along the solvent front will come out faster because it has got more affinity towards the solvent phase or the moving phase. So here I'm going to discuss you with a mixture of certain chemicals like methyl paraben, 4-aminobenzoic acid, and acetophenone. This is a standard kind of a mixture, and the compounds are mixed and then adsorbed onto silica, which is then loaded into solid sample cartridge. And for that matter, TLC plate was prepared. We found that yes, in the desired range of 0.1 to 0.5, you can find the separation of the samples, and then same conditions were taken for setting up the procedure in the flash chromatography. But separation outside this range may be possible, but the resolution may be reduced. We have found that if you have a RF of 0.6, 0.7, 0.8 like that, then also you can achieve the separation. There is no issue in that, but the resolution gets reduced. That is one thing given from the flash chromatographic point of view. Now, for separation of that particular mixture of methyl paraben, 4-aminobenzoic acid, and acetophenone, just an example has been given. You can see first the diagrams here, wherein it was run with using only the 10% ethyl acetate in hexane. So hexane is a solvent B, and ethyl acetate is solvent A here, and the concentration we can see is only 10% of ethyl acetate. Now, ethyl acetate is more polar in hexane than hexane, and you can see that the spots which we have got has got the top spot with 0.6 RF value, then the middle spot is having only 0.17, and then the last spot have not moved even from its point of application. So the third peak and through their literature, we know that the first peak is of the acetophenone, second peak is of methylparaben, and third is of the 4-amino benzoic acid. Now, what we have got on flash chromatography is in the form of a peak. Now, the peak that you are able to see in this graph is of the first spot, that is of acetophenone. So that is quite clear and visible, and it has shown the clear separation even at 10% of ethyl acetate. But if you find the second compound, that is the methylparaben, which has shown only 0.17 RF value on the TLC plate, is having very low resolution and very weak kind of a peak is available for isocratic separation to happen. So this is one condition. Now, how can we improve upon this particular separation can be seen from the next slide, wherein we have increased the concentration of ethyl acetate to 20%. So we have increased the polarity, and as a result of that, the top sample, which was showing 0.6 RF, now has moved to 0.73. The second spot, which was 0.17, has moved with the RF of 0.31. And the last spot, which was not moving at all at 10% ethyl acetate, has moved just up with 0.07. How the flash has identified it is, you can see the first peak is very clear. Second peak has improved as compared to that of the earlier one. So yes, the process is getting optimized. We can now have two constituents identified in a simple process or in a single process. But still, this third peak is eluding. We have not seen any catch of the detector has not sensed it, the third peak, and therefore again we have to optimize our solvent system for the separation of this. Now, what has been done is that again we increase the concentration of ethyl acetate, and we have seen that 30% of ethyl acetate has helped us a little bit. Now, you cannot increase the ethyl acetate much, because this first peak or the first spot, which was moving going towards the solvent front, is almost reaching up to the front. So 0.9 is its RF value, 0.1 is bottom, and 0.52 is the second spot. Now the first and second peaks look good now, and the third peak comes off the column but is not usable. So now you can see that 1, 2 very clearly. You can identify them. You can have a different definite separation of these two constituents, but still the third one is not as per the requirement or the as desired for separation. The resolution is not that fantastic, and therefore we were supposed to again try something bigger than this. Now, what is there in our hand is we increased it to 50% of ethyl acetate and 50% hexane. The result of that, you can see in the TLC plate, the first two spots merged with that of the solvent front. So you can have 0.92, 0.89 as RF value for the first two, and 0.42. So now the last spot has come into our range of clear separation and identification, and you can see that in the form of the peaks, there are two peaks merged with each other. Those are the spot number 1 and 2. However, the third one is now clear, discrete, and can be separated out as a single spot. And this is how on the chromatogram the first and second has overlap, as we can predict that, but the third peak is probably usable. So for the third peak, you have got the process of 50% ethyl acetate and 50% hexane. Now, this kind of a practice and practical and experimentation are needed for each and every compound or a composite sample, because of the variability in the nature of it. More so ever, it becomes very tricky if you are handling some kind of constants which are absolutely unknown to you, and with that a lot of experimentation is needed. For that matter, a lot of practice, patience, and persistence is needed while using this particular system. So TLC2 isocratic summary, if you take with that of the example that we discussed, we found that to purify the compounds individually, 20% ethyl acetate will purify the first sample, that is the acetophenone. So that process tells us that 20% ethyl acetate अगर आप रखते हैं तो पहला जो है वो बहुत अच्छे से separate हो जाएगा. But 30 to 40% ethyl acetate is needed to best purify the second peak. So that is a methyl paramine. However, 40 to 50% is needed for the last peak. So this is the kind of a primary understanding that we have got, and accordingly, what you need is to increase the gradient by your own self. To purify all three in a single run, what you need now is not the step gradient technique, but a continuous gradient solvent system is needed. And whether the system offers that, yes, this is what I wish to tell you, that for making the system user friendly, the software and the machinery is so nicely working together. The hardware and software is so nicely working together, is that they just fix the automatic gradient of two solvents, wherein the weak solvent. So the weak solvent should move first. Initial solvent should be weak enough that the samples are not moved at all. And normally the starting condition is 0% of B. The final solvent strength should be sufficiently strong. A default setting is 100% B, but this is not always necessary. So how to achieve desired separation of all three constituents without manually stepping up the gradient? So that can be achieved by the computer software, and the entire run is now going to be calculated on the basis of the column volumes. So the peak starts from, say, this stage to this stage, and how many test tubes will be filled at the bottom, and for that matter, how many column size of the solvent will be filled up. Say, for example, 50 ml is needed for one column fill. So how many such repetitions of the column fills will take place so that your constituent will come out? So that is called as column volume. So sometime if, say, for example, the first peak, the column volumes, maybe 3 to 4 columns, you will achieve the desired separation of the constituent. However, in case of the last sample, which is difficult to be eluted at first at 30% or that concentration, and for that matter, if you need to increase that gradient right up to 100% of ethyl acetate, we have seen that 50% ethyl acetate and 50% hexane had yielded separation of the last constituent as well. So can I have a system wherein I start with 0% of ethyl acetate and then increase it up to 100% of ethyl acetate? And this should happen by the automatic gradient increment system in the machine. So that is possible. And this is how we can say that the desired separation can be achieved. Here, this slide is clearly telling you how to choose two different solvents for the separation. So they say that let us pick up, say, 100% hexane, which is solvent A, which doesn't move the sample from the point of application. So that is your choice number one. जो बिल्कुल भी मूव नहीं कर सकता, ऐसा एक सॉल्वेंट चाहिए, और दूसरा ऐसा सॉल्वेंट चाहिए कि जो सबको बहुत आगे में लेके जाता है. So like 100% ethyl acetate was taken on the plate, and these two, एक जो बिल्कुल भी मूव नहीं कर सकता और एक जो पूरा उनको सॉल्वेंट फ्रंट पे लेके जाता है, ऐसे दो सॉल्वेंट्स they become ideal combination for achieving the desired separation of these constituents in this machine. Now this is the monitor of that machine. You can see that the sample name has to be introduced. So which sample you are taking, the column that you are using is automatically detected. So whether you have taken the 4-gram column, 30-gram column, or 300-gram column, once you fix it in under that arm of the column, it can automatically detect. Now, how much time you need to run this whole process? So here you can see that in the screen, the default process says that the separation process will go for 15 minutes. So automatically the gradient has been picked by the machine, and the solvent B percentage will go on increasing with the gradient time. And you can see that 100% solvent B will come at the 12 minutes, and it will be there for up to 15 minutes of run length. Whatever separation will be achieved, they will be identified here. How the solvent increment will be there, that also comes in this particular screen. What is the flow rate? Yes, that is also, you can either decide, or the machine will take it according to the standard default process. What kind of a detection you need, whether you want UV separation, UV identifiable range of constituents in focus, yes, then you can have the you can detect it at the desired wavelength. If you know that your constituent is having, say, not 254, but the lambda max of 310, yes, you can fix that and you can focus upon identity of that particular constituent of your interest. So all this is there, and then towards the collection side, you can always command whether you want to collect all the fractions which are coming out of the process of separation, or you want to collect only the peaks. Means the constituents, if detected, only that particular volume of the separated fraction you need to collect. So you can have a choice of that as well. So if there is a overpressure, you can decrease the flow rate. If there is a short and broad peaks, you can change the threshold. Threshold means here the precision of detecting can be improvised. If too many fractions are there, then you can collect peaks only or increase the fraction size, and you can insert the run nodes. So whatever observations are there while you run the process, you can keep on noting that just as you record your experimentation and the data collection on the registers, you can insert the run nodes which will be saved as an archive. So whatever your experiences, that you can record. Now here you can see that there are variable fraction sizes. So there are going to be the peaks. For if the peaks are going to come, then they will be collected in 6 ml sizes. So so that you can really separate it from the non-peak area, and say like for non-peak area you can have a 27 ml volume of collection, because you do not have the significant constituent in that. But here you can see in this graph the test tube number 8 to test tube number 10. If you really want to find out where my compound A has gone, it indicates that compound number A has been detected here at this particular gradient of the solvent B. Means here you can really connect to yourself that when it achieves the 40%, here if you start with this, so around 30-35% of your solvent B, if it is there, the peak has started, and then it has come down at say around 50%. So with the increment in the polarity of the solvents, the collection of the peaks can be achieved. And where this constituent has gone, in which test tube we have here, the number of test tubes are given. So from 8 to 10 number of test tubes, the compound A, you will find them in that particular test tubes. So dual wavelength detection is also possible. So you can fix the 2 wavelengths at a go, and you can have a parallel kind of a monitoring of whether the constituent is having 254 or the other wavelength also you can fix, and you can identify the ratio of separation. Ratio of the 2 wavelengths may also be optionally displayed during a peak. Now, detection wavelength is used for peak detection. That is, we have already spoken to you. Like here, 254 was ideal, but if you are having some other constituent which is having say lambda max of 220, you can have that additionally, and you can see 2 different color peaks are being followed in that particular panel. So this is how it goes, and the ratio of the 2 wavelengths is another point of affirmation of the constituent that we got. So basic information about the constituent can also be available at that particular time. Gradient optimizer is another facility that has been given, that if the time is going on, now you have 15 minutes of your time run, and if you want to change the gradient here, so you can just simply click the mouse on the screen and you can drag that particular line of gradient to your desire. So you can either increase or you can reduce the gradient to achieve the desired separation based on your own, we can say practical that is going on. Based on your own understanding about the compound, you can increase or decrease the concentration of solvents. So input the percentage B for the TLC plate. The basic information that you got from TLC also becomes the feed in the software of this flash chromatography, and based on the RF values which are fed by you for compound A or B or C, the system will automatically derive its gradient and will give you the desired separation. So simply enter the RF for your compounds as you have got here, and then based on that, the gradient will be optimized by the separation process. So RF to gradient, this is possible. So two components, their ratio of RF values, if they are less than 0.2, then it is, the monitoring the separation of that is quite possible. So closely placed constituents on the TLC plate can also be separated by notifying their delta RF. The run lengths can be either in the form of a time or in the form of a column volumes. So as I was telling you, you can decide whether how many number of column volumes you want to get filled, and again getting like that, say एक बार अगर column भर गया and same amount of quantity of solvent is passing through it. So on the basis of that, say like for 50 ml, I was telling you that the column is filled with the solvent once. Another 50 ml, when it goes through, it becomes 2 column volumes. So accordingly, you can have say like 34 column volumes here, as an example I have seen, and the 28 column volumes. So the run lengths of your isolation process will be based on your own understanding about the constituent that you are handling, and based on that, you can give a command of the percentage solvent B, means the gradient can be fixed as can be shown here. So you can simply click and drag, and while the process is going on, you can achieve that particular separation. So gradient optimizer is working for you. You can see here the gradient was kept same till we achieve a particular separation, and then the gradient was taken down. So this can be selected manually on the screen, and you can achieve the necessary separation. So this kind of separation of the constituent can be achieved. So gradient optimizer works. Here you can see that the peaks were very closely placed earlier. So like this, it was there, or earlier it was like just one single bundle of 2 constituents. We need separation, and if you just optimize the gradient based on your understanding of the chemistry of the constituent as well as the required solvent systems, then you can achieve this kind of separation of compound A and B. You can further make them properly placed, distinctly separated, so that there is no mix of constituents with each other. Gradient optimizer helps you in achieving that kind of a separation. Now limitations are also there. So RF has to be between 0.2 and 0.8, as we have seen in the example that even with 0.8, 0.84 that we had seen, that was acetophenol, and wherein 0.8 was achieved with 50% ethyl acetate and could be separated by using this system. RF must increase with increasing percentage. So it means that with the increase in polarity of the solvent that you are using in isocratic system of separation, your RF must also increase. Same solvent combination can be used as you have got from the TLC. So the basic information that you have to derive is from TLC, and that helps. So RF to gradient benefit can be seen because the data of RF value can be fed in the software of the automatic flash system, and you can achieve the separation. So I'm coming to the close of this demonstration. Normal gradient can be there. What remains in mind of a researcher is that to get 2 distinctly placed constituents, they should be absolutely separated from each other. They should be free from any mix-ups. They should be discrete, and one can really get them as a single discrete constituent, which can be taken up further for characterization purpose. So based on the column size also, you can have just like we have seen that the software can be of help in optimizing the gradient of the solvents in separation. Similarly, you can achieve that by selecting the proper columns. So the same separation can be achieved like this in 4-gram column, like this in 12-gram column, like this in 40-gram column, like this in 80-gram column, like this in 120-gram column, and you can keep on increasing the collection of the quantity or the yield of the separated constituent by increasing the column. And this is the maximum that column size that you have in the ready sep columns. And This is how. So the most amazing thing is that while you are running your system, the system is going on, the peaks are coming, the surround gradient is visible, and still if you wish to make any changes in the next minute of operation, yes, you can click and drag the gradient and you can change the system. You can change the wavelength at which you want to observe the next coming constituent. You can make a change. So that kind of a liberty is giving an upper hand, making the process of isolation more funful, interesting, and user friendly. So any parameter can be changed. Make changes anytime is the kind of working module that you have. And if you have this kind of a system in hand, definitely yes. If the say like in this case, we have seen that the constituent is coming a little bit late, and you feel that yes, you need some more time for the separation to take place, you can just drag it further and you can increase that time from say 16 minutes time here to 24 minutes time, so that nothing goes missed out and you can achieve the complete separation by the end of it. So what is at the end, and what if I did not have to be along with the machine during the whole process? There is no need for you to be present. You can just have this default procedure placed in this. You can load the sample and you can forget. You can have a cup of tea outside. You can be there in the lecture, or you can do some other experimentation at the same time. Machine is doing its own separation, and there will be automatic stoppage at the time of completion of your process. And you can see that the separated constituents are here shown at the final thing. The pink one constituent is available here in the test tube number say 2. The peak 2 is available in the form of a color. You can see, you can correlate that it is present in test tube number 12, and then 9, and then like that. So in which test tube which compound has been there secured for you, that is absolutely made available to you, and you can just pick up those test tubes and take out the desired constituent. Now what is there in additional is that there is automatic saving is there, and the data and the files automatically goes into the PDF system. So this is what is really needed for a system to be reliable, for a scientist to work, or for the researcher to work on the separation process, that whatever process that I have done, whether it has been recorded, yes, whether it can be reproduced, yes, you can use the same process by which you have achieved the desired separation wonderfully well, and you can reuse the same process henceforth without having much of your mind and deliberations at the end of it. So after moving from TLC to column, and then from column to the automatic flash system, the desired separation of the compound is achieved or not. Yes, it is usually 100% pure constituents are made available. Whether your process is saved there for further references, or whether you want to reuse again, yes. Whether your data, so whatever observations that you had in time during the separation, whether it is preserved or not, yes, everything is available. And with that, I'm going to just stop here with the deliberation, and then we can have a few questions if at all they are from the participants. Before I end up, I would like to have a prayer for all of you, because of the pandemic. We had been at home for a long period of time, and we are again coming back. So wishing you all the well-being that is necessary. And after having this prarthana, I'll end up my talk. So I'm reciting that. He Ishwar sabko sanmati de, आरोग्य दे, सबको सुख दे, आनंद और ऐश्वर्य दे, सबका भला कर, कल्याण कर, रक्षण कर, और तेरा मीठा नाम मुख में निरंतर रहने दे. So this Vishwa Prarthana is for well-being of you all. So this is given to us by Sadhguru Shri Vaman Pai of Jivan Vidya Mission. And finally, I'm coming to my last slide, wherein whatever experiences that we had, whatever learnings that we had has been with so many entities, and I would like to express sincere gratitude to all those sanstha's, my own university, my department, and so many other we can say organizations, my industry friends and collaborators. In particular, thanks to all my students and all of you who are here online with me for a long period of time. Thank you for patience listening, and hope I have served the objective of today's talk. Thank you so much.
Yes, thank you very much, sir.
My share, I'm stopping the share.
Yes, thank you very much, sir. And 100% you have served the objective of today's FDP. We will take 1 or 2 minutes for question answer session. So now session is open for question answer. You can unmute yourself and ask the question, please.
Hello, sir.
Devkade sir, yes.
Good morning.
Namaskar, sir.
सेशन सगळ्या गडबडीमध्ये सुद्धा मी तुमचं सेशन पूर्णतः ऐकत होतो. अतिशय त्याच्यामध्ये, कारण मला स्वतःला फ्लॅश क्रोमॅटोग्राफी घ्यायचं होतं आणि हे सगळं करायचं होतं. थॅलाडाईनची प्रोसेस झाली, सगळं झालं, पण फार अवघड झालं. आम्हाला ते खरेदीच झाली नाही कधी. त्याच्यात इच्छा होती करायची, काम ती तशीच राहून गेली. ते सगळं काम केल्यासारखं वाटलं तुमच्याकडे ते बघून अगदी. तर मला फक्त एकच प्रश्न विचारायचा आहे, म्हणजे आपण सबसिक्वेंट एक्सट्रॅक्शन करतो, तर whether we require to do the subsequent extraction with the flash also?
थोडा मध्ये आवाज अटकला होता, परत एकदा प्लीज रिपीट कराल का?
Subsequent extraction,
solvent extraction.
Yes, subsequent extraction. Whenever we are using column, we are doing subsequent extraction process. Whether the same process is to be done with the flash chromatography?
Not needed. Basically, the sample that you are going to take over the column, this flash chromatography. आमचा असा अनुभव राहिला की खूप कॉम्प्लेक्स जर सॅम्पल असेल, सपोज आपण म्हणूया की आपल्या टीएलसी प्लेट मध्ये 10 स्पॉट्स आपल्याला मिळेल आणि त्या 10 स्पॉट्स जे आहेत खूपच क्लोजली प्लेस्ड आहे, मग त्याचं आपण डायरेक्टली याच्यावरती फ्लॅश वरती करू शकतो का? तर मी पाहिलं की ते प्रॅक्टिकली तेवढं अचिवेबल नाही आहे. त्याच्यात काय होतं की मिक्स ऑफ फ्रॅक्शन्स यायचे, म्हणजे 3 कॉन्स्टिट्युएंट्स एका फ्रॅक्शन मध्ये आले, मग परत त्या तिघांना आलेलं जे काही वेगळं फ्रॅक्शन होतं त्याला परत आपल्याला वेगळ्या कॉलम वरती परत फ्लॅश क्रोमॅटोग्राफी मध्ये लोड करावं लागायचं आणि मग त्या 3 पैकी एक असा वेगळा करावा लागायचा. तर आम्ही काय विचार केला की आपण कॉलम मध्ये किंवा फ्लॅश मध्ये सॅम्पल घेण्याच्या आधी जर आपण त्याचं सॉल्व्हंट फ्रॅक्शनेशन जर करून घेतलं आणि असे जे कॉम्प्लेक्स जे एक्स्ट्रॅक्ट असतात त्याच्यामध्ये 10 असतात, 15 कॉन्स्टिट्युएंट असतात, 20 असतात, 25 असतात किंवा जास्त असू शकतात, त्यांना बेस्ड ऑन देअर अफिनिटी टुवर्ड्स दी डिफरंट सॉल्व्हंट्स त्याच्या सॉलिबिलिटीच्या बेसिसवरती आधीच आपण इव्हन सेपरेटिंग फनेलनी आपण केलं तरी हे अचिवेबल असतं की आपण 5 कॉन्स्टिट्युएंट्स असलेला एक फ्रॅक्शन जर आपल्याकडे असला आणि त्याला जर आपण कॉलम वरती टाकला आणि आपल्याला जर टीएलसी प्लेटचा डेटा आपल्याला सांगतोय की यांची प्रत्येकाची जी आरएफ व्हॅल्यू आहे ही एकामेकांच्या पेक्षा 0.2 नी सेपरेटेड आहे, से लाईक 0.3 आहे, 0.5 चा आहे, 0.7 चा आहे आणि 0.9 चा स्पॉट आलेला आहे एका पर्टिक्युलर सॉल्व्हंट सिस्टीम मध्ये. तर येस, असं जर असेल तर मग आपल्याला फ्लॅश क्रोमॅटोग्राफी मध्ये प्युअर कॉन्स्टिट्युएंट मिळणे जास्त पॉसिबल होतं आणि तसं करावं अशी माझा स्वतःचा अनुभव तसा राहिलेला आहे की आधी सॉल्व्हंट फ्रॅक्शनेशन आपण अचीव्ह करायला पाहिजे. त्याच्यातनं टीएलसी वरनं आपल्याला डेटा कळतो की त्याच्यामध्ये 3 ते 5 मॅक्सिमम एवढा कॉन्स्टिट्युएंट असला जर आपल्याला कंपाऊंड असेल तर ही फ्लॅश क्रोमॅटोग्राफी सिस्टीम आपल्यासाठी खूपच चांगली आहे.
तर आपल्याला विचारायचं होतं की आता तुमचा फ्लॅश आहे तर त्याचा डिटेक्टर फक्त युव्ही डिटेक्टर आहे का?
आता जे त्यांचं मशीन आलेलं आहे त्याच्यामध्ये पीडीए डिटेक्टर आलेला आहे आणि तो खूपच उपयोगी ठरतो नॅचरल प्रोडक्ट्स साठी किंवा अशा केमिकल साठी ज्याच्यासाठी तुमच्याकडे काही डेटा नाही आहे, तुमच्याकडे सपोज माहितीच नाही आहे की कुठले कॉन्स्टिट्युएंट आतनं इल्यूट होणार आहे आणि त्या इल्यूट होणाऱ्या कॉन्स्टिट्युएंटची काय लॅम्बडा मॅक्स आहे हे जर आपल्याला माहितीच नसेल तर अशा वेळेला आम्हाला अपेक्षित असं आहे की त्या डिटेक्टर सिस्टीमनी त्याला ओळखावं आणि त्या ओळखल्यानंतर त्याला सेपरेट आम्हाला काढून द्या आणि दॅट इज पॉसिबल. सो नाउ द सिस्टम इज इक्विप्ड विथ पीडीए डिटेक्टर विच वर्क्स इन द कम्प्लीट रेंज, विजिबल पासनं ते युव्ही पर्यंत सगळं त्याच्यामध्ये एकत्रित येतं आणि दॅट इज the kind of system which if at all you desire to purchase, you should go for a system with PDA detector.
येस सर. आम्हाला त्याच्यावरच अडकलं होतं की कुठला घ्यायचा, त्याच्यात तुम्ही पीडीए डिटेक्टर कुठला घ्यायचं, असं आम्ही हेच जस्टिफिकेशन दिलं तुम्ही दिलेलं, पण ते आमचं काही नाही.
कारण त्याच्यानी किंमत वाढते ही नक्कीच गोष्ट आहे. बाजारामध्ये आता आणखी दुसरे पण फ्लॅश आलेले आहे की ज्याला आपण म्हणूया की स्वस्त आहेत, परंतु मी पाहिलं की जोपर्यंत सिस्टम व्हॅलिडेट नसते किंवा त्याच्यावरती अशा प्रकारचे आधी जर काही प्रयोगच झालेले नसेल तर तशा सिस्टीमवरती खूप जास्त आपण भरोशाने राहू नये. आणि ठीक आहे, म्हणजे बीफार्म वगैरे लेवलला दाखवायला डेमॉन्स्ट्रेबल काही इक्विपमेंट्स राहू शकतात, परंतु unless you have a fully automatic system with you which works based on the proper data that you have derived from TLC, तोपर्यंत मला असं वाटतं की ती सिस्टीम आपल्याला हेल्प करू शकणार नाही. तर रोबस्ट सिस्टीम हवी, रिप्रोड्युसिबल सिस्टीम हवी, आणि त्याच्यासाठी आपल्याला चांगला ब्रँडच हवा असं मला सारखं वाटतं. हा, त्याच्यासारखं आपण मशीन डेफिनेटली बनवू शकू जर आपण हा जो आपला अनुभव जो आहे तो इन द फॉर्म ऑफ फीडबॅक जर आपण एखाद्या मशीन मॅन्युफॅक्चररला सांगितला तर कदाचित स्वस्त आणि याच्यासारखी अशी मशीन सुद्धा आपण बनवू शकतो. पण इतकी लिबर्टी आपल्याकडे नसते. म्हणजे आपल्याला जे गव्हर्नमेंट सेक्टरमध्ये आहेत त्यांनी जर मशीन जर प्रोक्यूर करायची असली वी कॅनॉट गेट इट फॅब्रिकेटेड. ती आपल्यासाठी एक मर्यादा आहे. आपल्याला ते ब्रँडचं वाटल्यास ते जास्त पैसे देतील एकदाचे, परंतु आपल्याला इंजिनिअरिंग करून आपण आणलेलं मशीन आपण आपल्या इकडे वापरू शकत नाही. पण आपले जे मित्र आहेत जे प्रायव्हेट कॉलेजमधले आहेत त्यांच्यासाठी ते डेफिनेटली अशा प्रकारचं फॅब्रिकेट करून स्वस्तामध्ये अशा प्रकारचे मशीन्स घेऊ शकतात टू अचीव द डिझायर्ड सेपरेशन.
थँक्यू व्हेरी मच सर. अतिशय लेक्चर. खरंच आम्हाला अगदी असं वाटलं की मी स्वतःच आता फ्लॅश वापरला आणि माझी जी राहिलेली इच्छा आहे ती कम्प्लीट केली.
चला सर, धन्यवाद. देवकाते सर.
धन्यवाद. धन्यवाद.
Sir, there are various compliments on your session in the chat box. I will read some of that.
Oh, please.
Very informative session. Very nice session, sir. It cleared doubts about flash chromatography. A very informative and elaborative session. Thank you, Dr. Itankar, sir, for extensive knowledge sharing in the session. There are a lot of comments which are there in the chat box because this session was very friendly. Means as said by Devkate sir, it feel like we all are doing the same thing what you have done.
Right.
So anyway, give me permission to end up this session. So I will come to the thanks slide. So thank you very much to Dr. P.R. Itankar sir for sparing time, and he has spent 90 minutes with us, and he talked from column to flash, and he has explained all the particular thing that how the column and how the flash now are available, what are the importance of flash, what are the limitations of flash chromatography. He has all the things taken in the 90-minute session. So thank you very much, sir.
Thank you. And if anybody wish to have so the experience of that, we can arrange the training programs. That is not at all a problem for we to disseminate information and knowledge related with the flash chromatography. And though we are now short of moving from UV to, when I had purchased it was having only the UV, but we will still pursue for the higher end flash chromatography, which is of great help to the natural product chemists. So thank you so much, and we wish to have multiple collaborative projects with you all. There are a few sanstha's with whom I have been working for validation of the traditional systems of medicine. One amongst that is a sanstha called as Govigyan Anusandhan Kendra at Developar. And what I really felt is that treasure of traditional knowledge, which is lacking the scientific validation, needs a lot of hands to support those kind of consolidation and validation of the traditional this thing. So I may request you all to note down my number or take my number from Manu Charde sir, and if you desire to end into a memorandum of understanding for doing research along with Govigyan Anusandhan Kendra or with my laboratory, we are open to help you in that, and it would be a great service back to the society, and which I feel only pharmacy professionals can only do and can lead the nation in becoming Vishwaguru in traditional systems of medicines.
Yes,
So
sir.
thank you so much.
I request Hosmani sir to hand over the virtual certificate to Itankar sir for his presentation during this faculty development program. So thank you very much, sir. We will mail you this certificate to your email.
Yeah.
So, next speaker, Dr. Ganesh Kokate sir is also there.
Yeah.
And he is talking on the HPLC today. So thank you, sir. Thank you very much.
Thank you so much.
Thank you.
Thank you.
Over to you, Hosmani sir.
Good afternoon, all. So I request Sauri sir to start the next session, please.
Yes, sir. I am audible, sir.
Yes, sir.
Good afternoon to everyone. I welcome back to all the participants for today's second session. So it's now my great pleasure to introduce our second speaker, who is having very much experience on the basics of HPLC and its advanced application. He is none other than Dr. Ganesh Kokate sir. He has completed his post-graduation, that is MSc Organic Chemistry, under Shivaji University in 2001. He's having more experience, including analytical development laboratory. Here about 15 years of experience he's having in this. And in the field of application specialist, that include pre-cell and post-cell activities. Here about 5-year experience is having. Dr. Ganesh Kokate is having experience in purification techniques, elucidation of structures with the help of spectroscopic data